One of the first tests that we do with concrete testing is we test for the slump of the concrete, and this is important with the understanding the consistency and the fluidity of the concrete as it's incorporated onto the project. It kind of varies depending on the type of work that you do, so whether it's structural concrete or pavement concrete, our slump ranges from about 1 to 5 inches. Again, depending on the type of work. The slump of the concrete is important to test throughout the work because you want to make sure that the concrete is consistent. The next test that we do is we test for the air content. And this is crucial in concrete. We have 2 different types of way that we test for the air content of concrete. And one of them is done by a pressure method, and the other one is a volumetric rollometer test. So it is dependent on the type of aggregate that we use in the concrete, and the one that's shown in the video is based on the pressure method. The importance of testing for air content in concrete is that we have our own standards that we follow within the spec book, and the air content ranges from 5% to 9% depending on the type of work that we're doing and the type of concrete. And this is important that we test the air content because there are 2 different types of air that can appear in concrete mixes. And one of them is entrained air and one is entrapped air. So the entrained air in concrete consists of millions of microscopic concrete air bubbles in the concrete. And this is really important for the durability of the concrete and ensuring that during freeze-thaw cycles, we don't have issues that would result in cracking of pavement. As far as the entrapped air, that is more so due to how the concrete is worked and how it's handled out in the field. So by doing our testing, we want to make sure that we eliminate the entrapped air and only capture the entrained air that's in the concrete mixes. So throughout the process, the pressure meter actually compresses the air particles, and that's how we're able to read the air content for the concrete. The final test that we do is we test for the compression and the strength of concrete itself. So we make cylinders, and once those cylinders are made, we let them cure and we break them after 28 days. And once we do the compression in our test lab, we're able to determine the final strength of the concrete. Here's an example of one of our cylinders that we did break. And this actually broke at a strength of 4,200 psi. So that's pounds per square inches. So there are some differences that we can find in materials that do pass versus materials that don't. Some of those include the actual consistency of the concrete. Sometimes if the gradations of aggregates are off, or if there's too much water that's used in the concrete, you get very inconsistent looking material. There are also issues if material like this does end up out on the project. It can result in premature failures such as cracking. You can get spalling out on bridge decks, and you see a lot of visual issues as well as some structural components that you might not see immediately, but you can see down the road. So you may notice out on certain construction projects that once the concrete is placed, we have burlap that's put down on the concrete, and we have hoses that run across. And that is our process of curing the concrete. So it sounds a little contradicting to actually keep concrete wet in order for it to harden and cure, but the process of having the water with the concrete helps with the hydration, and it is crucial to the curing process. If the project does not have properly cured concrete, that can also result in premature failures as well.